At high voltages, that is voltages of 1 kV or above, electricity is unforgiving. 7 out of 10 people are killed on contact. The life of a highly skilled and experienced engineer, a loved and loving family member, can end in seconds. Fatal and serious incidents happen for 4 main reasons: technical failure of machinery or components, poor communication or understanding of a work situation, people acting in an apparently careless or even illogical way, often as a result of being distracted, and people knowingly taking risks and not following procedures. A significant contributing factor in incidents is unsafe behavior. We all make mistakes. We all have times when we are tired, stressed, distracted, or in a hurry. Working with medium to high voltage means one simple mistake can be fatal. Because the consequences are so serious, there are rules and procedures to help minimize risk. These rules form a safe system of work and must be understood and practiced by everyone concerned. Common sense alone is not enough. We all have our own responsibilities within this safe system of work, but we are also responsible for the lives of our colleagues.
Hello, Alan.
Hi.
Have you spoken to the Stevenson plans about using our safety rules?
Yeah, I've spoken to the manager. He's happy to fully comply with ABB's procedures.
And Sam's had all the training he needs to create a safe working area at Stevenson?
Yeah, he's fully authorised to do it. I have total confidence in him.
How about his new workmate?
Managers have the initial responsibility to ensure a safe system of work is in place and that their employees have been trained to follow it. This may be defined by the customer or by ABB or a combination of both. Either way, it must be clearly communicated and understood. To help all employees involved in working with medium and high voltage electricity create a safe system of work, we have taken best practice from around the world and distilled it into 7 steps designed to protect you. The steps are intended for people who are properly trained to work on medium and high voltage equipment in service. They may be time-consuming to carry out, but they are all there for a reason. Each step helps keep you and your colleagues safe. If one step should fail, the next one provides a safety net. Each step should be repeated as necessary throughout a job. Different people may be responsible for different steps, but you are all responsible for the safety of each other. Work safely for yourself and for the protection of everyone in your team. If you feel others are not following the steps, then speak up, either to your manager or to your workmates. Your action could save a life. The 7 steps that save lives. Step 1. Clearly identify the work location. Use your senses, sight, sound, and smell, and your common sense to check that the live equipment is in good order. Risk assessment is continued throughout the job. During most projects, workers will need to continuously go in and out of the work area. Therefore, the equipment being worked on needs to be clearly identified to avoid mistakes being made. Substations normally contain several identical-looking pieces of equipment, so cables and lines may need special identification. You can't be 100% sure of everything that needs to be identified until all the other steps are completed. Step 2. Disconnect and secure against reconnection. Equipment must be disconnected from all possible points of supply and then secured by means of a lock and tag type procedure to ensure it cannot accidentally become live. Step 3. Protect against any other live parts. Protection can be in the form of warning notices attached to all the panels that are not going to be worked on. Flame-proof overalls should be worn. Additional physical barriers, such as locks and insulating screens, must be applied if the live equipment is exposed. By clearly identifying the nearby parts, which must not be touched, you are also helping maintain Step 1. You then need to recheck that you have the correct point of work. Step 4. Take special precautions when close to bare conductors. There are situations where potentially live equipment can be close enough for contact to happen accidentally, including when you put up the safety barriers or insulated screens designed to protect you. It is sometimes impossible to be sure that even connections under cover are safe. There may be an error in earlier steps, or the connections may have a dangerous voltage induced from nearby power equipment. By removing the cover, you are in a situation where a slip or accidental movement could result in contact. You must take special precautions, for example, by wearing insulated gloves. You should definitely take special precautions if you are within a meter of live connections, but use your common sense regarding the work situation. In poor light or with difficult access, for example, you may need to use special precautions even though the connections are more than a meter away. Step 5. Check the installation is dead. This must be by means of a proper test instrument. Ensure you check that the tester is working before your tests. During the test, take precaution to keep clear of the connections. After the tests, recheck the test instrument. Step 6. Carry out earthing and short-circuiting. Earthing has two main functions. Firstly, it ensures the equipment is free of any residual charge or induced voltages during the work. Secondly, it should be capable of short-circuiting any fault current caused by a failure to disconnect in Step 2. A number of earths may be applied between any source of supply and the point of work. Circuit breakers and switches usually have a facility to earth the equipment. If possible, earth the part that is being worked on, or at least make sure the earth is visible from where the work is being carried out. Step 7. Issue a permit to work. Now we have created a safe working area, we need to formalize this with a permit to work. This is a formal safety document, and it has a number of functions. It states clearly what the work is and where it will be carried out. It summarizes the precautions that have been taken to create the safe working area. The person responsible for these two steps signs it to show that the permit is correct. This proves they are handing the equipment over in a safe condition. At this point, the person issuing the permit will formally identify the point of work and discuss any safety issues. The permit clearly defines individual responsibilities. The person receiving the permit confirms that they understand the contents by signing it. He is now responsible for keeping a safe working area. Neither he nor anyone else can alter this until the permit is formally cleared by him and returned to the issuer for cancellation. A permit to work must still be completed in situations where all the preparation and work is carried out by the same person. It acts as a written risk assessment, and the signature formally shows that the necessary safety precautions have been followed. The recipient is responsible for the safety of everyone in his work party, and anyone else who may affect his working area, regardless of their position or seniority. You will have many other things you need to consider in your daily work, but it is crucial you take your part in the 7 steps seriously. Step 1. Clearly identify the work location. Step 2. Disconnect and secure against reconnection. Step 3. Protect against any other live parts. Step 4. Take special precautions when close to bare conductors. Step 5. Check the installation is dead. Step 6. Carry out earthing and short-circuiting. Step 7. Issue a permit to work. Follow these steps at all times, whatever your role. By completing safety procedures thoroughly, you are helping to save lives. Don't risk becoming another statistic. You owe it to your family, friends, colleagues, and yourself to stay alive. Keep to the 7 steps. Keep safe.